Okay, good morning friends, and welcome to the BSc part first, chemistry paper second, that is organic chemistry. Today we want to see the first unit, that is fundamentals of organic chemistry. In that, the topic is reactive intermediate. We know that when starting compound and reagent are going to react with each other, they will form the product. In between them, some species are generated, are called as the reactive intermediates. In that, already we have seen the carbocations. Today we want to see the carbanions. Now what is carbanions, how they are generated, what is the structure, and what are their reactions, we want to see one by one in details. So carbanions is an ionic species which carries negative charge on carbon. Carbanion is the ionic species which carries negative charge on carbon. That means, or it is denoted by R minus. Okay, so this R is the carbon. This R, it have many adjacent group, that means CH2, CH3, like that. Okay, so this R minus is denoted as a carbanions. Now these carbanions are generated by the heterolytic bond fissions, or there are some methods which are used for the generation of that R minus. So we want to see, for example, when this carbon hydrogen bond is heterolytically break, that means both electron transfer on the carbon. At that time, it will give a negative charge on carbon and H plus. This CH3 minus is called as a carbanion. As carbon have negative charge means pair of electrons. This bond is nothing but the pair of electrons. Both electron in heterolytic bond fission are transferred on that carbon, therefore it carries negative charge. Therefore that negative charge on carbon is called the carbanion. So we want to see the methods of generation of carbanions. So first method is generation of carbanion is from unsaturated compounds. Now this CH3, CH double bond, CH2 is the unsaturated compound. Okay, when this nucleophile is electron rich species. Now this carbon double bond is act as a electrophile. This nucleophile donates its electron to that electron deficient species, and it will forms the bond with this carbon. This nucleophile forms the bond with that carbon. To stabilize or to maintain the valency of that carbon, one of the carbon double bond has been break, and both electron transfer on the adjacent carbon. So it will forms CH3, CH minus, CH2, and here nucleophile carbon bond is generated, and this CH minus is called as a carbanion. This is one of the method of generation of carbanions by using unsaturated compounds. Then we want to see the second method, that is generation of carbanions from heterolytic bond fission. Okay, from heterolysis means generally the carbon hydrogen, carbon carboxylic group and carbon metal bonds are undergoes the heterolysis. Heterolysis means both electron transfer on the one of the carbon or one of the atom. Here carbon hydrogen bond, carbon carbon bond and carbon metal bonds, in that those atom or the atom which is more electronegative, the electron transfer on that atom, and that's why we want to see one by one example. For example, When this aldehyde molecule is react with base, we can use base like NaOH in presence of ether, NaOH in presence of water. Okay, when this base is abstract that proton, and it will forms a carbanion. Okay, so by using base and any hydrogen which is a acidic. Why it is acidic? Because the hydrogen it is present on carbon which is adjacent to that carbonyl compound, and carbonyl compound is electron withdrawing species. That's why this hydrogen becomes slightly acidic, and when it reacts with base, it will abstracted by that base and it forms a carbanion. So this is one of the method of generation of carbanion. Then by using CC bond heterolysis, for example, when we are having such a alkoxy carbons, this O minus gives its electron to in the resonance, and at that time it will undergo the heterolysis and it will forms a carbanion. R minus plus CO2 molecule or carbon dioxide has been eliminated from that. It is called as a decomposition reaction, or it is also called as a decarboxylation reaction. The molecule undergoes decomposition, that's why it is called as a decomposition reaction, and carbonyl group has been eliminated, that's why it is also called as a decarboxylation reaction. The third example of that heterolysis is carbon metal bond. Me stands for metal. When this carbon metal bond is undergoes the heterolysis, here carbon is a more electronegative as compared to metal, that's why both electrons are transferred on that carbon, and that forms a carbanion, and here metal carries positive charge as it loses its electron and both electron transfer on that carbon. So it is called as a carbon metal bond heterolysis. So this is the second method of generation of carbanions. We want to see the next method, that is abstraction of proton. Third method of generation of carbanion is abstraction of proton from acidic compounds. For example, para-nitrotoluene. Now this CS3, that 3 hydrogens present on that carbon, they becomes acidic. Why becomes acidic? Because the benzene ring having nitro group. This nitro group is the electron withdrawing group. It pull electron towards itself, and that's why the CS3, that is toluene methyl group, it becomes acidic. When you are going to use any kind of the base like OH minus, NaOH and other that, they will abstract that proton very easily because this hydrogen becomes acidic, and this bond, carbon hydrogen bond, is get heterolytically broken, and it will generate a carbanion like this. This is one of the most commonly used method of generation of the carbanions. Then another example is cyclopentadiene. The hydrogen present on allylic position of that carbon-carbon double bonds, this becomes acidic, and when you want to use any kind of the base, that base abstracts that proton and it undergoes the heterolysis fission or heterolytic fission, and it will generate a carbanion. So this is one of the most commonly used method of the generation of carbanions by abstracting the protons. These are the two examples of generation of that carbanions. So here we have seen 3 methods of generation of the carbanions. Then we want to see the structure of carbanion. As we know that the carbon which is having negative charge is called as a carbanions. Now there are, according to their hybridization, this carbanion have two structures. One is called as trigonal pyramidal, it is having sp3 hybridization, and therefore the structure or geometry of that carbanion is about trigonal pyramidal. The another structure of the carbanion is trigonal planar. This is because that carbon which is having sp2 hybridization. Okay, so there are two types of the structure or geometry of that carbanion. One is of trigonal pyramidal because of the sp3 hybridization of the carbon, and another one is the planar structure or planar geometry. This is because of the sp2 hybridization of that carbon. That pair of electrons are present in the p orbital, that's why it has sp2 hybridization, while this p orbital is vacant. Therefore, it is called as a sp3 hybridization, and therefore it acquires a trigonal pyramidal geometry, while that sp2 hybridized carbon acquires planar geometry. So this is about the structure of the carbanions. Then we want to see the stability of carbanion. Okay, as we know that our carbanion, it is the electron rich species, as it has negative charge on that carbon. Therefore, to stabilize that negative charge, the groups which are present on that or which are present adjacent to that carbon, these are going to affect on that stability of that carbon. Okay, so we want to see the first effect, that is called as electronegativity. Okay, when you are having electron withdrawing group adjacent to that carbon, they will pull electron towards itself and they stabilizes that extra electrons or negative charge on that carbon. Therefore, the groups which are present, which that should be electron withdrawing, or they should have some electronegativity. For example, when you are having hybridization, sp hybridized carbon, it is more stable carbanion as compared to sp2 hybridized carbanion, and that sp2 hybridized carbon is again more stable as compared to sp3 hybridized carbon. Okay, this is because of the electronegativity. The electronegativity of that carbon or the adjacent to that carbon is more as compared to sp2 hybridized carbon. Therefore, it pull electron towards itself, and that's why that negative charge means extra electrons are going to stabilize on that carbon. The another effect is called as inductive effect. Okay, so there are two kinds of the inductive effect, plus I and minus I. Here our carbanion is already electron rich, therefore when you are having electron donating inductive effect, that means a plus I effect, it destabilizes that carbon. Therefore, on carbanion, the group like or the group which shows minus I effect, that means the groups which pull electron towards itself, that groups are going to stabilize our carbanion. For example, okay, now you can see here example, there are 3 chlorine atoms which are present on that carbanion carbon. Because of that chlorine, they shows minus I effect, strong minus I effect, because of all the 3 chlorines are electronegative elements, they pull electron towards itself, and that's why that extra electrons are going to stabilize by that electronegative elements by showing minus I effect. Here one chlorine atom has been replaced by hydrogen atom, therefore the minus I effect has been decreased, therefore stability also decreases from left to right. As we got to see the methane or methane carbanion, which is less stable as compared to the another carbanions, because there is no any electronegative element which shows the minus I effect. There are all hydrogen atoms which shows the plus I effect, and that's why that electron they shows electron donating inductive effect, that means plus I, and therefore the carbanion becomes unstable or destable. Then we want to see the next part, that is the reactions of carbanions. As we know, the electron carbanion is electron rich species. It generally reacts with the electron deficient species. This is the rule of that electrochemistry. Okay, when one of the electron deficient species is going to attracted towards the electron rich species, our carbanion is the electron rich species. Therefore, it will react with some electron deficient species. Okay, so first reaction, that is called as the elimination reaction. Okay, now what happened when this compound reacts with the strong base like OET minus or NaOET minus, it will abstract that acidic proton. Okay, it will abstract that acidic proton. At that time, that carbon hydrogen bond undergoes the heterolytic bond fission and it will forms a carbanion. So it will forms PH, CH minus and CH2Br. Now this is the slow step. What happened? This carbanion generated, it gives electron to the adjacent carbon. To maintain the valency of that carbon bromine bond undergoes the heterolysis and both electron transfer on that bromine. So Br is eliminated as a Br minus. So I will write here minus Br minus. So in that case, hydrogen and Br has been eliminated from that starting compound. Therefore, this reaction is called as elimination reaction and it will forms a new product which is called as a styrene. In that, carbon-carbon double bond has been generated. Okay, the first we want to see this reaction in details. When any kind of the base is reacted with that compound, it will abstract that proton because this proton is slightly acidic. Therefore, that proton is easily abstracted. At the time of abstraction, that carbon-hydrogen bond undergoes the heterolytic bond fission. That's why it generated the carbanions. This carbanion gives its electron to the next carbon, and at that time, this carbon-bromine bond undergoes the heterolytic fission and bromine has been eliminated to form the new alkene compounds, that is called as a styrene. Then we want to see the next reaction, that is the displacement reaction. Displacement reaction means the groups which are displaced from one molecule to another molecule. For example, this CH3 minus which is stabilized by Na plus. So it is a sodium methoxide. Okay, sodium methide, CH3Na. When this react with CH3Br, that is methyl bromide, that CH3 minus is act as a carbanion. It will donate its electron to that electron deficient carbon because this carbon is become electron deficient as it bonded with the bromine. Bromine is more electronegative as compared to carbon. That's why it pull electron from that carbon and that carbon becomes electron deficient. Therefore, this carbon or carbanion which is electron rich, it gives its electron to that carbon which is electron deficient. At that time, to maintain the valency of carbon, that carbon bromine bond has been broken and both electron transfer on that bromine. So the new bond is formed between two carbons, that CH3 and that CH3. The new bond is generated, it is called as the ethane plus, that Na plus is stabilized, that Br minus. So it becomes NaBr. So this type of the reaction is called as a displacement reaction, that CH3 has been displaced from that CH3Na to CH3. Therefore it is called as a displacement reaction. The another type of the reaction is called as rearrangement reaction. Generally Carbanion shows less kind of the rearrangement reaction, but here we want to see one of the example for this. This carbon having 3 phenyl groups. Okay, triphenyl carbon is there, and phenate reacts with sodium. Sodium gives its electron to that chlorine or to that carbon, and it will forms a carbanion here. CH2 minus, and it is stabilized by Na plus. Okay. Now this generated carbanions, it gives electron to that carbon. At the same time, one of the benzyl group or phenyl group has been shifted from this carbon to this. Okay. And therefore it will forms a new compound or new product with a carbanion. Now you can see here in that second stage, carbanion is generated on that CH2. In the rearrangement or in the next step, what happened? One of the phenyl group has been shifted from that carbon to this carbon. Therefore, that carbanion is also shifted from this CH2 to C. This is called as a rearrangement reaction. Okay, I hope you get this. Okay, thank you.